Hi, my name is Abigail Chiu. In this video, I will be giving a tutorial on how to use Apes, which stands for Automated Peak Picking of Spectra, and IPIN, which stands for Probabilistic Interaction Network of Evidence for Automated Backbone and Sidechain. Okay, so I have already opened my three spectra that I will be using. So on the left here, I have NHSQC, which is what I'll be using as reference, HNCACB in the middle, with the purple as the positive values and the green as the negative values. And then at the end, I have CBCACONH. And in case you're wondering how I got the white background, I just did two-letter code CI to invert the colors. Okay, so now that these are open, I am going to load my sequence information. I believe I've already done so, but to show you how to get there, type it in the two-letter code SQ. This opens a little window like this. And as you can see, I have already stored my sequence file, but to do so, you can just click on Browse, select your sequence file, and then click OK, and that's it. So I will click Cancel because it's already in there, and there's no need to override it. So we're going to change the threshold viewing level so that we can view the peaks a little better. To do that, just type two-letter code VT to open the view setting. And here, this little section here, you can use it to change the spectrums you have, adjust whichever settings for which spectrum you would like. So we're in NHSQC. So this aspect here changes the peak size. So you can increase the peak size by increasing it like so. We can also just use our mouse. Your mouse scroll can also use it to zoom in a little to see if you can see a little better. That looks okay. And then we will check this box for axes atom names to see what each axis is displaying. Apply. Okay. Oh, I okayed on accident, but VT again. So because I click on this spectrum before I type VT, it recognizes that it's changing the view settings for HNCACB. And again, same thing here. We're going to zoom in a little bit, and then we will increase the aspect a little bit, like that's okay, just enough so you can see. And then check the box for axes atom names to see what's on your axes, and then that's it. Don't click OK just yet because we have one final spectrum. We're going to change this view to CBCACONH. And then from here, it looks about okay, but I think we can increase it a little bit. That's okay. And then check the box for axes atom names again, apply, okay. So now that everything is in visible, clear view, we're going to confirm that we do not have any peaks at all before starting. So type in the two-letter code PV. This opens the view list like so. So here shows you the list of experiments in this project, and then your peaks are also right here, and you can see there are no peaks right here. So we're done confirming. And so next, let's take a look at, now we're going to run Apes actually first before we do anything else. So to do that, we'll type in the two-letter code AE. It will say, do you want to use the stored sequence file? Yes, because we already stored the sequence file earlier. So it recognizes it. Then this window will pop up, and all you have to do is match the types of spectrum you have to the experiments that they are. So in case you named it something else besides NHSQC, this is what this is for. So the NHSQC spectrum is the NHSQC experiment. So HNCACB right here. And then last but not least, the CBCACONH. There is a difference between this experiment and this experiment. This is saying that the carbon alpha is not being shown, but in our case, the carbon alpha is being shown. So we use this experiment and not the one below HNCACB. So select that, and then afterwards, just click on Run Apes. Do you want to launch Apes followed by IPIN automated assignment? No, because I'll be walking you through on how to run IPIN separately if you wanted to do IPIN just by itself. So, but in a realistic situation, if you would like to, you can. So you can see here the progress of it. And now there's a message that says Apes peak picking finished. Please validate results. Okay. We no longer need this window. We can close it. So let's confirm that Apes has found the peaks. So to do that, we can type the two-letter code PV. This will show you the view list, and you can see from before where the peaks were 0, now we have some numbers right here. Close it. But we want to see these peaks in reality. So close this window, and then we're going to look at the actual peak list. So to do that, first select on the NHSQC spectrum. So select it here, so that's good. Type LT to open the peak list. And in case if it doesn't already show the data heights, you can go to options and you can check the box right here for data height, and this is what you want, and then you can sort by data height. So I want to sort by data height, which it does. Apply, okay. So that's how you can get this column right here if you don't already have it. So we're gonna see whether or not all the peaks were picked, and maybe if there were some noise peaks picked on accident. So if you go all the way down to the smallest data height value, we can double check to see. It's a bit small, so we can zoom in by using, again, your scroll bar mouse, or you can type the two-letter code ZI. You can see here that this is actually not a peak. How do you know it's not a peak? Well, if there was an X over a peak like so, then that is a peak, but otherwise it is not a peak. But actually, interesting. Oh, this is blocking the view. This right here shouldn't be a peak. So we can just select on it and then click Control D or the delete button on your keyboard. Not the backspace, but the delete button can also delete. So next we have something like this. That is also not a peak. So if it was a peak, it'd be over, it would look something like this. That would be a peak, but this is not a peak. So again, delete. Is that a peak? That is a peak. Is that a peak? Yes, that's a peak. And then, oh, this wasn't a peak. This does not seem to be a peak. It's a very weak signal. So I wouldn't say this was a peak. So to delete again, I'm going to delete that off. That's a peak, that's a peak, that's a peak, 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 peak. So you basically just go over, keep going up to see if these are all peaks. But typically, as the data height increases, the Apes is more likely to be accurate in picking these peaks. So once we're done with NHSQC, we're going to move on to HNCACB. Click on the spectrum, PV, oh sorry, LT, that's what I mean. LT to get the peak list. Just like before, I already have my data height selected, but if you don't, you can go to under options, make sure that this box is checked, and then you sort by data height. Yes, and then apply, okay. So you will get something like this. And because HNCACB has positive and negative data height values, we're going to start by looking at the strongest negative data height. So let's look at the strongest negative data height. So if you scroll all the way down, you're going to see your largest, your most negative data height value. Double click on it. Again, it's a bit, zoom in a little bit. That right there is indeed a peak, because you see it's very clearly over an actual peak. This peak has been picked. Go up, yes, 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 yep. So because it's all the most negative values are all peaks, you want to look at the smallest negative value and the smallest positive value. So if we scroll up this list, we can get to where they change, the negative value changes to positive value, and look around that region, that range. A little bit higher, or we can just use our mouse and find it. Just find that one. Oh, found it. You see? So this is our smallest negative peak, and this is our smallest positive peak. So if you double click on the smallest positive, you see that there's nothing on there. It's over a black empty space. So this is not a peak. It shouldn't even be picked. So we can delete it by doing Control D, or just the delete button on your keyboard. We'll continue going up. You see as well, this is not a peak, so we can delete it. Not a peak. Not a peak. This is not a peak. There's nothing underneath it. This is also not a peak. This X mark is not over anything. Okay, so now we look at the smallest positive values going up. So now we'll go down. Is that a peak? There's a peak here, but this is not a peak here. So you would delete this because there's nothing here. And if you look across here as well in the CBCA-CONH, there's nothing there as well. So this is not a peak. So delete. This one, not a peak. You see there's nothing over here. So not a peak. Next, is this a peak? This is not a peak. Delete. Is this a peak? Not a peak. So we'll move on to CBCA-CONH. So again, LT, you get the spectrum peak list right here. And again, you go to options, data height, sort by data height as well. You check these boxes to get that option. Apply, okay. Okay, so again, for the CBCNOH, it should be similar to NHSQC. You just go straight down to the smallest value, and then you zoom in. Oh, to see whether or not this is a peak. This is not a peak. Is this a peak? This is not a peak. Now that we have all the peaks being done, we're gonna validate the peaks even further with strip plot. So to do that, you're gonna type the two-letter code SP. This opens a window like this, and under show, go to select spectra, select strip spectra, and then you're gonna see a window like so. You're gonna click on the CBCA-CONH first, make the checkbox there, and then the HNCACB next. So the order of which that you select does matter, because whichever one you select first is going to be shown up first. So show spectrum name under each strip, apply, okay. So afterwards, we're gonna select all the peaks in NHSQC. To do that, we're gonna do a two-letter code PA, or Control A works as well. Click the plus peak. Okay, so all the strip plots have been made. So you can select this button right here a couple times to make the strip width a little smaller, because you don't quite actually need it. Okay, that's as small as it'll go. So you can also click on the zoom in on all strips, this plus button to zoom in on all strips. Okay, so let's zoom in, that works. Okay, so we want to compare to validate each peak, and to do that, we're gonna delete any noise peaks and add any missing peaks, and then zoom up and down, and then move around the z-axis plane as well if needed. And then, so to start out, we're gonna look by looking at the first pair of strips. So this is a pair, one CBCA-CONH and one HNCACB is a pair. And if you are not familiar, you use the CBCONH to see the I-1 residue. So imagine I is the residue that you want to label, and I-1 is going to be the peak before it. So how it works is that CBCA-CONH has the carbon alpha and carbon beta of the I-1 residue, the residue before the one you actually need, and then HNCACB will include the carbon alpha and carbon beta peaks of the I-1 residue and of the I residue. So in a sense, you kind of move along like that. So there's gonna be 2 in the first column and there should be 4 in the second column, but it does differ if you do have a glycine. Yeah, so let's take a look at the first pair. So in the first pair, you see a peak selected here. Your mouse cursor has two lines going across it for you to double check. There's a peak right here, and next to it there is a peak right here, so that's good. On these two here is the same. There's a peak right here that's been picked. There's a peak right here that's also been picked. So these are going to be your I-1 carbon alpha and carbon beta peaks. Next, you're going to look at your I-1s. So there's one right here, and then there should be one up here. There is one. So these two strip plots. So this pair of strip plots are good. So once you're done with them, you can click on this. This button right here, the minus SELE. This deletes the selected strip plot. So click on it twice because we're done with those two. So we'll move on to our next pair. Okay, so we only look, if we zoom in, we only look at the peaks that are in the middle of the strip plots. So before there was one on the side right here, yeah, we don't look at that. We just look at this one right here in the middle. And then we can scroll down. So there's one peak right here, one peak right here. These are our I-1 residue, carbon alpha, carbon beta peaks. Next, we have our I residue. Next, okay, there's 4. Okay, so this works. This is correct. This pair is good, so we can delete them. And then you just go down the list like so. So we'll do another one. It's a little too zoom in, so we can zoom back out a little bit. Let's see. Okay, so there's one right here. Okay, that works. And then the next one, there's another one up here. That's good, but for some reason, this peak has 2 peaks selected. So let's zoom back out and see. So those were our I-1. So let's look at our I. There's one right here. And then, nope, just this one right here. So meaning that our second I residue peak must be overlapped here somewhere. That's okay. And so we're done with this pair. Just delete it, click on it, and delete the selected strip. And so you can go down the list to verify all these peaks. There's a lot, but the process has become much more easier because now you're mostly just confirming that peaks have been selected. So that is it for Apes. And so now we will move on to IPIN. So to start an IPIN, you could either run IPIN right away after you run Apes, as you saw that there was an option to do so after you do Apes. But I'm going to show you how to do IPIN if you weren't, if your peaks have already been picked and you just want to run IPIN. So to do that, you're going to type in the 2-letter code EP, not in the text box here, but EP. This opens a window like so. You can put your name and email here so you can receive the results. This is so that you can save the results. If you don't want to do it, you don't need to. You can also just leave this window open and it will do that. Input your sequence files. The POKY already remembers my sequence file, so I'm going to leave it as is. And then next, we're going to select the spectrum that we have and then make sure that they match up the correct experiment type. NHSQC. One of my spectrum is called NHSQC, and the experiment type is indeed NHSQC. So click Add. Next is going to be CBCACONH. Experiment type is going to be not this one. It's going to be this one, where the CA is not in parentheses because carbon alpha is indeed visible in the spectrum. Next, HNCACB, exactly. Oh, it's going to be this one right here. So add. So these are the 3 that you should have. And then you can click on submit to run the job. So a message shows IPIN's job is submitted. Okay. And so now we will wait. Okay, so as you are waiting on your IPIN job, you can check its status by clicking on this box right here. And my status here says finished. So do you want to download and unpack IPIN package? Yes, I do. Oh, do you want to plot the POKY secondary structure prediction results? Yes. Okay. So this plot here shows the probability of each residue number and their predicted secondary structure. Yeah. So that is what, oh, yes, I'm going to close. So the next one is, do you want to plot IPIN chemical shift assignment results? Yes. So this is a probability bar graph that describes the assignment probabilities for each residue. The different colors indicate different confidence level. So greens are all confidence. Gray means it wasn't able to be predicted. It looks pretty good. Okay. Close this plot. Do you want to plot the LACS chemical shift validation results? Yes. Okay. Oh. So the chemical shift outliers and chemical shift reference errors can be found from a program called LACS, LACS. Here we have the carbon alpha and carbon beta. So it predicts whether all the chemical shifts are within a certain range and then look for the possible outliers. It uses your benchmark data set and some kind of training data set to generate an expected value based on the BMRB database statistics. So then those in red are far from the expected value. So in my case, 123 carbon beta is far from the expected value. This could occur for two reasons. One might be that this specific chemical shift is too far away from the expected value, or it has used the wrong chemical shift for reference. But either way, I only have one. Oh, your mouse can zoom in. I only have one residue that is far from expected. So yes, I want to close these two plots. And if you put your name and email into the job, it will email you these results as well. So you can access these on a web page. So do you want to plot the POKY hydrophobic prediction results? Yes. So this graph right here, this is a hydrophobicity graph that predicts hydrophobicity using the benchmark database called POKY. It is a way to map out the interior residue of the protein, and it depends on the environment. It predicts whether some of the residues are in hydrophobic core and find out which ones are the nonpolar residues that are hydrophobic. It calculates the hydrophobicity to find the interior residue, and yeah, it simulates the structure. So this is what this bar graph tells you. Do you want to close? Yes. So the next graph is to whether or not you want to visualize the ordered regions. So yes. Oh, Talos N is not finished. We'll wait a couple of minutes, but yes. We want to create IPIN labels? Yes. Created? Yes. Do you want to assign peaks with IPIN labels higher than 0.5 probability? A few seconds will be needed? Yes. Okay, 439 of 487 peaks were assigned. 0 peaks have duplicated assignments in the same spectrum. Great. So now it tells me to use PineSparky extensions to use IPIN labels. Start with a 2-letter code PP, and then floating IPIN labels can be selected with a 2-letter code SE. Great. Okay. So all of these are done. For Talos N, I believe, we can come back to this in a second. But Talos N is a software that predicts secondary structure of protein by using the backbone dihedral angles. The dihedral angles can be calculated from the chemical shifts of backbone atoms. So we'll go over that in just a minute, because mine is not done yet. But from here, you can let's see. From here, you can do your validation. So now that everything is done, you can validate them. You can also delete the floating labels. So to do that, you can just type the 2-letter code SE to select all floating labels, and then press the delete button on your computer or Control-D to delete them. So all that was done. So now there's no more floating labels. Oh, there we go. Okay. So for validation, there are two methods. So there's the pine graph assigner and then there's the strip plots. So first I'll show what the pine graph assigner looks like. So to do that, clicking the POKY area and then type the two-letter code PP. Do you want to use the store for themselves? Yes. Okay. So a window like this will pop up. So the single arrow here, this single arrow goes to the next residue. So it moves the one in the middle, the residues in the middle is what you're looking at. And if you do double arrow, it skips to every 10 residue. So we were at residue number 1, and then now we are at 11. So you can check whether or not the NH right here, for each residue are assigned. For the first residue, however, it might not be assigned. It's not going to be assigned because there's no I-1 residue before it. And remember, when you're assigning each residue, it uses the I-1 in order to find I. Does that make sense? So for the second residue, this was found because there's an I-1 to be used to find it. If there are values next to the NH bond, it has a black outline around it and it's been assigned. So if you click on it, you can click on it and it turns purple. If it does, it means you have changed it. But if you click on the nitrogen and the NHSQC spectra list is where your spectras are at, you can see that this has indeed been labeled. And then typically, yes, the first residue is not assigned because there's no I-1 residue that can be used. If it's not, you can just go down the list to see whether or not these are all assigned. But if they're not assigned, you can use the strip plot to assign. The pine graph assigner allows you to see atom by atom assignment. Yeah, and then there's also aside from pine graph assigner, there's also the pine assigner that allows you to do peak by peak assignment and choose the possible candidate for that peak as well. So for IPIN at least, we mainly use pine graph assigner and strip plot, but you just go down the list to see if it's been picked or not. So that's for pine graph assigner. And so for strip plot, just like we did with Apes, we're going to type the two-letter code SP. Let's open the strip plot like this. Before we get into strip plot, let's see if the Talos N plot has been made. Okay, we'll click on the checkbox again. Yes, I do want to download and unpack. No, I don't want to plot the pecan. I don't want to plot the IPIN chemical because I already did that. No lax, no PAXI. I think this is the only one that we did. We haven't seen it yet, but visualize the ordered regions. Yes. Okay. So this is what the Talos N looks like. Like I said, this is the Talos N is a software that predicts the secondary structure of protein by using the backbone dihedral angles. And the dihedral angles can be calculated from the chemical shifts of a backbone atom. So if you know the dihedral angle, we can predict the secondary structure of the protein. This graph predicts the order parameter for each residue. Good secondary structures have higher probability values. So these ones in the beginning and these ones around residue number 50 doesn't have as high probability values. And once again, you can get all of these graphs. You should get an email that allows you to get all the graphs as well. So you guys want to close it. There's no need to plot them because get the labels because we already did that. So back to the strip plot. So like before, if you do not remember, for strip plots, you're going to do show, select strip spectra. And then here you're going to see two windows. See a window like this, and then you're going to select the CBCA-CONH first, and then HNCA-CB after. And again, your show spectrum name under each strip should be selected because you do want to see the spectrum name, and the order of which experiment you select first does matter because as that is going to be your, which is what's going to be shown first. So apply, okay. So we are going to Same thing as before. So select all the peaks. So PA to select all the peaks in NHSQC. We're going to click on add selected peaks. Like so. Okay. So to minimize the width of it, so we can click on this button right here to minimize its width. It's pretty good. You can zoom in a little with this plus button, zoom out with the minus, with a 2 sign. Okay. So this is what it should overall look like. So we can double check. It's a little bit hard to see because they're all a bit overlapped. So you can move the labels around to make sure. But it's the same thing as before. You're basically checking to see whether or not this peak is in. So we're looking for this peak right here. Oh. Okay, we can take a look and see. So this peak right here is the M1 carbon beta. And here we have, oh, yep, M1 carbon beta right here. So the name is a bit long. We can also for sure like minimize the name size. More information on how to adjust your name size can be found in under the help menu. But yes, this peak is here. And then if we look down this list right here, oh, this is the one for this peak right here. We can move the labels around. This is for the M1 carbon alpha. And across from it is this peak right here. Let's see, is this label there? Oh my, maybe it wasn't such a good idea too. Let's expand a little bit better. There we go, okay. Now we can see a little better. This peak right here. Oh my goodness. It seems that it's not, that this ornament, that this is not labeled. So we can do that by copy and pasting it to that peak. So we'll just OC and then here OP. There we go. But it seems, okay. Control V. Oh no. This peak's already picked, so we'll delete that. Now we'll do it again. So take this and then OC, OP. Oh no, wait. Where did it go? Oh no, okay. Oh no, okay, wait. So we don't, strange, okay. Oh, should be back over here, okay. Okay, we're gonna copy and paste this ornament over here. There we go, okay. So now this peak is properly picked and you should get something like this. We can make it a little wider so you can see it better. So now this label is saying that this peak is I-1, your I-1 is in the middle, the M1CA, and then it can be used to find your second second residue, your I residue. So then if you look down this line, so the other two besides this one and this one is going to be this one right here, which is indeed label. It's just a lot of labels are, it's a little bit difficult. No, this is not the right label. I believe this is the point. Yep, that's it. Okay. So you can see this label is indicating that this peak that's in the middle, again, we are only looking at the peaks in the middle of the strip plots. This is the carbon beta of the I residue, the second residue. which is correct. And yeah, I think it's a little bit difficult to see, but I believe, oh, seems that is it for these two plots, but it looks okay. So we can delete these two selected, and then you just continue on. But that is it for validating strip plots, how to use IPIN and how to use Apes. But basically, you get some predictions and then you use strip plots at the end to validate as well. So that is the end of this tutorial. Thank you all for listening. Yes, have a good rest of your day.